I'm Anil Kumar, sharing with you a test question on graphing rectangular equations. In this particular example, we'll actually convert the rectangular equation into polar form and then graph. The question here is, graph the equation x square plus y square whole square equals to 4 times x square minus y square. Now, first step here is to convert the equation into polar form. For that, we'll use the relations x square plus y square equals to r square, and we know x is equals to r cos theta and y is equals to r sine theta, right? That should help us to convert the given equation in polar form. So the equation here is x square plus y square whole square equals to 4 times x square minus y square. This is the equation. Now x square plus y square is r square, so I could write this as r square whole square equals to 4 times x square r square cos square theta minus y square is r square sine square theta, right? Now we could write this as r to the power of 4 equals to 4 times r square is common, so we could write this as cos square theta minus sine square theta. Now can you tell me what is cos square theta minus sine square theta? Well, it is cos 2 theta. So I'll write this as r to the power of 4 equals to 4r square times cos 2 theta, right? So cos square theta minus sine square theta is cos 2 theta, so I replace that. Now dividing by r square, we can get r square equals to, so r square r to the power of 4, we're dividing that, 4 cos 2 theta, and r will be equals to square root of 4 cos 2 theta, that is square root of 4 is 2, so 2 square root of cos 2 theta. So that is the polar equation of the given rectangular equation, right? Now in this polar equation, we realize one thing, that the cos 2 theta is within the radical sign and its value should be positive, right? So cos 2 theta will be negative if I take the value of theta greater than pi by 4, right? Then it will be negative. So pi by 4 will give me cos 2 times pi by 4 is pi by 2. And if I take a value more than pi by 2, then this will be a negative value. This is one thing to remember. Second thing is, when we are doing polar coordinates, it's a good idea to find the symmetry, right? So let us find the symmetry for this particular function. Now, if I write f of minus theta, what do I get? That means replacing 2 theta with minus 2 theta. So if I write f of minus theta, then let us say f theta is 2. So f theta equals to r, which is 2 times cos 2 theta. Then f of minus theta will be 2 times square root of cos of minus 2 theta. And cos is even function, so it is going to give you 2 square root cos 2 theta, right? So this is exactly equal to f of theta. Is that okay? So that shows that the given function is symmetric about which axis? About the polar axis, right? About this polar axis. I should not have x here. About polar axis. Correct. So we get one kind of symmetry in this particular case, and that is about polar axis. Now let's look into it further. If I check the value for f of pi minus theta, what do I get? For f of pi minus theta, we will get 2 times square root of cos 2 times pi minus theta, right? So that is, replace this theta with pi minus theta, and that gives us 2 square root of, now it is cos of 2 pi minus 2 theta, is it okay? And this is equals to, again, square root of cos 2 theta. So this is also equals to f of theta, right? So this is f of theta. So that shows that the given function is symmetric about which axis? The y, the vertical y axis. Is it okay? Now how does that help us? Well, these two symmetries which we have learned just now for the function, which is symmetric about the polar axis, that means the graph which is on the side between theta equals to 0 to pi can be reflected on the polar axis. So we need only values from 0 to pi, right? But we also know that this graph is symmetric about y-axis. That means the graph can be reflected on the y-axis. That is to say that for us, the values from 0 to pi by 2 are sufficient. Do you see that part? So finding symmetries really help us to define the values which we should be looking into to sketch the graph, right? So that is the kind of idea. Now, I have limited space. So what I'll do here is I'll mark this space for further calculations. So we'll try to make a table of values and find the value for r equals to 2 times square root of cos 2 theta, and based on those values we'll sketch. Now remember one more thing, cos 2 theta is within the square root, so we can actually maximum go up to pi by 4, right? Okay, so what we will do here is we'll kind of make a table so that we can create some values. So let me sketch, we'll use this space, okay. So I'll take very few values to begin with. Let's take theta and calculate f theta, which is equals to 2 square root of cos 2 theta. Is it okay? That is the function which we are looking into. So we'll take only values up to pi by 2. So we can begin with 0. So if I write 0, cos of 0, is 1. So that gives me 2 times 1 as 2. And now let me take a value, which is, let's say, pi by 8. So pi by 8 I have taken because 2 times pi by 8 will give me pi by 4, right? So let us use the calculator to calculate this value. So we have 2 times square root of cos, 2 times, within bracket, we have theta as pi by 8, right? So it is pi divided by 8, bracket close, and 2 brackets close, okay. And let's see how much this value is. This is 1.681. So let me write down this value is 1.68, let's say. And now let's see the value for pi by 4. So pi by 4 times 2 is pi by 2, and cos pi by 2 is 0. So we get this value as 0. Is that okay? Now we can try values more than pi by 4. But since that value will give us negative value, so any value beyond pi by 4 and less than pi by 2, right? This is our pi by 4 line, right? So in this region, if I take 3 pi by 8, for example, in that case, we'll get imaginary numbers, right? We do not get real numbers, since within the square root, we will get negative value, right? So those values are not possible. So these are the 3 values which we have, and they will help us to sketch the graph. Now, let us plot these values on the polar coordinate. First one is 0, 2. That means the angle theta is 0 and 2 is the r value. So distance from the pole is 2. The second is pi by 8, 1.68. We have pi by 4. Let me just draw another angle here. Let's say this is pi by 8 for us, okay? So that is pi by 8 for us. Pi by 8, 1.68, which is, this is 1, this is 2, more than half. Let's take this point as 1.68. For pi by 4, the value is 0. That means right at the origin. So the graph which we get here is kind of like this. Do you see that? So that is the graph which we get. Connecting these points, we get our graph. That is what we get. Now what do you know about this? We know from the symmetries that it is symmetric about the polar axis. So that gives you this point. Could be, let me sketch here, pi by 8 bisecting this angle, right? Okay, fine. So that gives us that symmetric will be a point here. So joining this, we will get our graph as, is that okay? So kind of like this. Now we also know that this is symmetric about the y-axis, correct? And therefore we'll get a reflection here on this point. So that gives us a figure like kind of infinity. Do you see that? Kind of infinity, right? This goes like this. So we get this shape of the graph for the given function, right? So that is how we could sketch the function with few values once we understand the symmetry. And I hope it helps you to understand how easy it is to graph curves with the help of polar equations. A very complicated equation in rectangular form can be graphed by converting it into polar form and taking few values. I'm Anil Kumar, and I hope that helps. Thank you and all the best.